Okay, this is Math 105 Section 5.5, which we'll cover at the same time as 6.4, so watch those two together. We'll do 5.5 first. Okay, so we're talking about the inverse of trigonometric functions and their graphs. So for a function to have an inverse, it must be 1-to-1, right? But our trig functions are not 1-to-1, okay? So they don't have inverses as they stand, okay? However, if we restrict the domains of the functions, okay, so we can make them 1-to-1, okay, in such a way that the resulting functions are 1-to-1. So we're going to force our trig functions to be 1-to-1 by restricting our domains to be just one cycle. In fact, for sine and cosine, we're going to restrict it to half a cycle. So for the sine, we're going to restrict the domain to the interval minus pi over 2 to plus pi over 2, okay? And we do that because sine is 1-to-1 on this interval, okay? And it also attains each of its values of the y of the range on this interval. So what we're looking at is sine. Normally our sine looks like this, right? Going up and down. Goes up and then down and then up again, and then it goes down and up again here. What we're going to do is we're going to restrict it, so we just use, I'll use red to scratch it out, but we're going to scratch it out here and everywhere else, okay? So we're only going to look at this part where it goes from minus pi over 2 here to plus pi over 2 here, okay? So we're just going to look at like that S part there is all we're going to look at. And that makes it 1-to-1. So this is minus pi over 2 on the x. And this is plus pi over 2 on the x. Okay. So we're going to restrict it to just that S there. We're going to get rid of all the stuff that I scratched out in red. Okay. And you see how if we do that, it is 1-to-1, that we can only cross it once, passes a horizontal line test. So we'll just look at minus pi over 2 to plus pi over 2. It's half a cycle, right? It's not even the full sine cycle. Okay, so we can see here's our sine curve. We're just going to use the red there. Okay, so it goes from minus pi over 2 to plus pi over 2, and we just have that like little s there. Okay, so if we define y equals sine of x, where x is between minus pi over 2 and plus pi over 2, we can talk about the inverse because it's now 1-to-1. So we're just going to look at this little part. Okay, so we have to make sure we say x is between minus pi over 2 and plus pi over 2 only. Okay, so we now have the inverse sine function. Oops. We now have the inverse sine function on this restricted domain, okay? And we write that like this, y equals sine negative 1 of x. So that's inverse sine of x, okay? Now what we're doing when we graph it is we reflect the graph of y equals sine of x on the line y equals x, okay? So we'll look at this in class and you can see it a little more clearly, but basically we took the sine curve, that the restricted one, and reflected it across the line y equals x. Okay, so the definition of the inverse sine function, we write it as sine to the minus 1. Remember, that's not to the minus 1 power. It's sine, inverse sine. So now our domain is minus 1-to-1. Remember, we're switching x and y. And our range is minus pi over 2 to plus pi over 2. So we switch the domain and range, right? So the domain, so inverse sine is going to take a number between minus 1 and plus 1 and give you an angle, basically, as an answer, as an output, between minus pi over 2 and plus pi over 2. Okay. So remember where that comes from. We took x equals, or y equals sine of x, right? And when you switch x and y, you get x equals sine of y, okay? And then if you write it with y by itself, you get y equals inverse sine of x. So that's how we write inverse sine of x. So remember, these are the same thing, okay? X equals sine of y is the same as y equals inverse sine of x, okay? Some other names we give it, we also call the inverse sine arcsine, or ARCSIN. So if you see that in your calculator, that means inverse sine. Okay. So let's think about what this is. So y equals inverse sine of x is the number in the interval minus pi over 2, pi over 2, whose sine is x. Okay. In other words, we're given what the sine of the angle is, and we're going to find out what the angle is. Okay. So we're going backwards. That's what inverse sine is. It's the backward sine. Okay. And then we can also say this: sine of the inverse sine of x is x. Remember, we're taking the function of its inverse. So if you start with x, and then you take the inverse sine, then you take the sine, which undoes the inverse, you get back to x again. So that's kind of definition of an inverse function. Okay, and that gives us our cancellation properties, basically taking a function of its inverse. So we take a sine of the inverse sine of x, we get x. Okay. Now that says x has to be between -1 and +1 because we're starting with inverse sine here. Okay, so that means you have to follow the domain of inverse sine, which is -1 to +1. Okay, and then doing the opposite, doing sine of x first and then taking the inverse sine of that will give us x, back to where we started. And here x has to be between -pi/2 and +pi/2 because we're starting with sine of x, and the domain of sine of x is -pi/2 and pi/2 for this particular function. You know, we're talking about inverse sine. Remember, we have to limit the domain. Okay. So when evaluating expressions involving inverse sine, we need to remember that the range of inverse sine is the interval -pi/2 +pi/2. Okay. So the range of inverse sine is an angle between -pi/2 and +pi/2 only. Okay, let's look at an example. Inverse sine of sine of pi/3. Okay. Since pi/3 is in that interval, -pi/2 +pi/2, we can just say it cancels out. So we get pi/3. Okay. So we're using our cancellation property there. Because pi/3 is where we want it to be, between -pi/2 and +pi/2, then we could say the inverse sine of sine of pi/3 is pi/3. Okay. B is a little bit different. If we take the inverse sine of sine of 2 pi/3, this angle is not between -pi/2 and +pi/2, so we have to evaluate this first. Okay, so we have to find the sine of 2 pi/3. Okay, and that gives us square root of 3 over 2. Okay, now the inverse sine of square root of 3 over 2 is not 2 pi/3 because it has to be an angle between -pi/2 and +pi/2. So think of it this way on our unit circle. When we're talking about inverse sine, we can only use an angle that goes like this, up to pi/2, or an angle that goes like that, down to -pi/2. Okay, so 2 pi/3 takes us over here, right? So we can't use that angle when we talk about inverse sine. Remember, inverse sine, we're going to get an angle, but it's got to be an angle that either goes this way, up to pi/2, or backwards, down to -pi/2. Okay, and where we get square root of 3 over 2 for our y is at pi/3. Okay, so that would be up here. Okay, so this doesn't cancel out because 2 pi/3 is not between -pi/2 and +pi/2. And this is what we mean when we say, you know, x -pi/2 and +pi/2, x is between -pi/2, x is between -pi/2 and +pi/2, is that we can only do that on our circle. Okay, and now let's talk about inverse cosine function. Okay, similarly for inverse cosine, we have to limit our domain, but we have to do it a little bit differently. Okay, so here's our cosine function, right? Starts at 1, you know, and then it goes down to 0 and down to -1, then back to 0, then back to 1, right? Well, if we want to limit this so it's 1 to 1, we can't limit it from -pi/2 to +pi/2 because it's still not 1 to 1 there, and it doesn't cover the whole range of values. But if we start at 0, at x equals 0, and go to pi, and just use this part, okay, 0 to pi, now it's going down from 1 to -1, and it's 1 to 1. It passes the horizontal line test. So here we're going to limit our domain for inverse cosine from 0 to pi. So here's our cosine curve. We're just going to use the red. Okay. So just to summarize that, domain of the cosine function is restricted to the interval 0 to pi. Okay. The resulting function is 1 to 1 and it has an inverse. Remember, we have to have 1 to 1 to have an inverse. Okay. And we chose this interval because on it, cosine attains each of its values exactly once. Okay. It covers all the values, right? So this is how we define cosine when we're talking about inverse cosine. Y equals cosine of x. X is between 0 and pi. Okay, so the definition of the inverse cosine function. Cosine inverse with domain -1 to +1 and range 0 to pi. Now remember, we're doing y equals cosine of x to start as our function. Inverse means you switch x and y, so that gives us x equals cosine of y. And then we write y by itself, y equals inverse cosine of x. Remember, these are the same. Okay. And again, we can call this, another word for that is arc cosine or arc cos. Okay. So y equals cosine of inverse cosine of x is the number on the interval 0 pi whose cosine is x. Okay. And then we have these cancellation properties similar to what we had for sine. Okay. So cosine of inverse cosine of x is x when x is between -1 and +1. And again, that's because, you know, we're doing inverse cosine first, which means we have to have x has to be between -1 and +1 because that's the domain of inverse cosine. Okay, and then inverse cosine of x gives us x. That cancels out for 0, x between 0 and pi. Okay, now that's because we're doing cosine first, and our domain of cosine is 0 to pi. Okay, so we have to have x between 0 and pi. But these will cancel out, just like they do for sine. We just have to be careful. If our angle is not between 0 and pi, then it doesn't cancel out. We have to figure out what angle will work there. Okay, here's our graph of y equals inverse cosine of x. It's shown, we obtained that by reflecting the graph of y equals cosine of x from 0 to pi on the line y equals x. So we'll look at this in class, and we'll see how this give you a better idea what that looks like. But we're doing that from reflecting that restricted domain cosine of x across the line y equals x. Okay, here's some examples. Inverse cosine of 2 pi over 3. Now, because 2 pi over 3 is in 0 pi, remember we're using 0 pi for inverse cosine, it cancels. So this just becomes 2 pi over 3. Okay. Now here it's not going to cancel because we're taking cosine of 5 pi over 3, which is not in the interval 0 pi. So the inverse cosine of 5 pi over 3, we have to actually evaluate this cosine of 5 pi over 3. Okay. Cosine of 5 pi over 3 is 1/2, so we're going to take the inverse cosine of 1/2 and find an angle between 0 and pi that gives us a cosine equal to 1/2. So let's talk about what this means. When you say inverse cosine of some number, right, it has to be between -1 and +1, first of all. But we say, okay, I'm looking for an angle where my cosine equals 1/2. And that angle has to be between 0 and pi. Okay, so that would be pi over 3. So to show you on the circle, what we're doing for inverse cosine is we've got to look at an angle that goes like that. We can only go in the first or second quadrant forward. Okay, so 5 pi over 3 takes us over here, right? And in fact, it takes us over here. It takes us in the fourth quadrant. So we can't go there, right? So we can't say this cancels out and gives us 5 pi over 3. So we have to evaluate this, get the half, and then find the angle going this way, only half a circle, that gives us an x equal to 1/2, right, which would be pi over 3, plus pi over 3, so it'd be there. So that's how we get that. Okay, let's talk about inverse tangent. If we just take one cycle of the inverse tangent function, like the interval minus pi over 2 to plus pi over 2, then it's 1-to-1. Okay, so restrict the domain of the tangent function to the interval minus pi over 2 to plus pi over 2, which is one cycle, to get a 1-to-1 function. Okay, so our definition of the inverse tangent function, inverse tangent. Our domain is all reals now because remember tangent can go from -infinity to +infinity. So we switch them, we get all reals for domain. And our range is minus pi over 2 to plus pi over 2. Okay, we don't include the endpoints here because they're undefined. Okay, so again, like with this one, we started with tangent. We start with y equals tangent of x as our original function. Then we switch x and y to get x equals tangent of y. So that's the inverse. And then we want to solve for y. So that gives us y equals inverse tangent of x. Okay. Sometimes we also call that arctangent or arctan. Okay. So y equals inverse tangent of x is the number in the interval minus pi over 2 to plus pi over 2 whose tangent is x. Okay, so here's our cancellation properties for inverse tangent. So if we take tangent of inverse tangent of x, we get x when x is all reals. The reason for that is because we're taking inverse tangent first, and the domain of that function is all reals. Okay, so we have to say x can be any real number. Okay, and then if we do it the other way, we say inverse tangent of x is x. Okay, for x between minus pi over 2 and plus pi over 2. Okay, and that's because we're doing the tangent of x first, and here we're limiting our domain to minus pi over 2 to plus pi over 2. So this would cancel out if that x is between minus pi over 2 and plus pi over 2. So here's our graph of tangent of x. We're just taking one cycle, that middle cycle, that cycle that goes through the origin, the red one. So now the inverse function, this might not seem obvious to you, but when we take this and we graph the inverse, the red one, we reflect it across y equals x, and it gives us this. So it turns your vertical asymptotes into horizontal asymptotes. So the whole thing gets turned 90 degrees and then it gets flipped. Okay, so across the x-axis. So we turn it 90 degrees and then flip it. So, but that's a reflection. And I'll show you in class how the graphs relate to each other, the tangent and inverse tangent. But we're just using this red cycle because we can't. It has to be 1 to 1. We can't use these, So we have to go between minus pi over 2 and plus pi over 2 only for our output for tangent of for input for tangent of x, which would be our output for inverse tangent. Okay, so let's look at some examples. Let's find inverse tangent of 1. So we're looking for a number on the interval minus pi over 2 to plus pi over 2 where our tangent equals 1. In other words, we're looking for an angle between here and here where our tangent is 1. And we know that that's pi over 4. So think of our angle has to go like this. Has to either go first quadrant or fourth quadrant backwards. Okay, we can only go plus pi over 2 or minus pi over 2. That's what this indicates. Okay, so to get a tangent of 1, you'll remember that's when we're halfway between the first, halfway through the first quadrant, which is pi over 4. Okay, so inverse tangent of 1 is pi over 4. And again, interpret this as our looking for an angle either going this way to plus pi over 2 or this way to minus pi over 2 where our tangents equal to 1. Okay. Now let's look at B. We're looking for an angle in the first quadrant or the fourth quadrant, going forwards or back, going positive into the first quadrant or negative into the fourth quadrant, where my tangent square root of 3. Okay. So that would be at pi over 3 because our sine is square root of 3 over 2 and our cosine is 1/2. So because at pi over 3, your tangent will be square root of 3. Okay, so that's how we get inverse tangent of square root of 3. Okay, now for inverse tangent of 20. Okay, this is saying we're looking for an angle between minus pi over 2 and plus pi over 2 again, where our tangent's equal to 20. Remember, tangent doesn't have to be between minus 1 and plus 1. It can go. It's all reals, right? So this is possible, right? So we're going to go, now we're going to do it in radian mode because we're going to find our answer in radians. Because remember, it's going to give us an angle, but it's going to give our angle, if we want our answer in radians, we would keep it in radian mode. So we take inverse tangent of 20. We'd use a calculator for this. This is something we wouldn't do by hand. Okay. So we're saying our tangent is equal to 20. Let's find the angle in radians that gives between minus pi over 2 and plus pi over 2. That gives us this. And that gives us, with a calculator, it's about minus 1.52084. Now, that's in radians, and think about in radians, pi over 2 radians is about, it's about 1.56. So minus pi over 2 radians is about minus 1.52. So this, about minus 1.56. So this does fall within the within minus pi over 2 and plus pi over 2 radians. Okay, so barely, but it does fall in there. Okay, we're not going to talk about inverse cotangent, inverse secant, inverse cosecant in this video lecture. I'm going to talk about it in class and kind of use some examples on how we do it. I don't want to get too hung up on the graphs. So, but you can think of, with inverse cotangent, inverse secant, inverse cosecant, we're just taking the reciprocals of inverse sine, inverse cotangent, inverse sine, inverse tangent, inverse cosine. Okay. Of its respective cofunction. So we'll look at that in class. Okay, now go on to section 6.5, and we'll finish up. 6.4, and we'll kind of continue our discussion of inverse trig functions from a triangle approach.